Hey there everybody, thanks for watching my little video here. We're going to talk a little bit about probability in this video, and I want to discuss a classic battle that you see in math classes studying this topic, the probability of A and B versus the probability of A or B. All right, it's a classic problem where you have to decide what you're going to do as a math student to calculate the correct probability. Now, this video is about probability, and as you've already seen if you are studying this topic in your math class, that you see lots of problems about coins flipping in the air and about dice rolling and about cards being pulled out of a deck. All that stuff is very good, and it's a way to illustrate certain principles, and we use them because we're assuming that people are generally familiar with those things. We might use other things like basketball or sports or some other kind of thing where you are familiar enough with the topic so that the principle involved, the mathematical principle, becomes more apparent. I'm not going to do any of that stuff in this video. I want to be much more general in this video, and I just want to talk in a general sense about the probability of two things happening. And one of those things we'll call A, and the other one we'll call B, right? There's your two things. So if A and B, if these two events are being considered to happen at the same time, we call that an intersection, all right? An intersection is A and B happening at the same time. On the other hand, if we're talking about either A or B happening, and that's using the word or there, that's called a union, all right? Now, if you think about this for a second, remember, probability is always a fraction, okay? So if A and B must happen at the same time, that means that my chances are going to go down. My probability will decrease, right? Because it's just harder to get two things to happen at once as opposed to just one thing happening. So an A and B situation, an intersection, is always a decrease in probability. On the other hand, a union where A and B can either A or B could happen, then that means my probability is going up. Because I'm happy if A wins, I'm happy if B wins, they're both good, my chances are now improved. So a union increases probability while an intersection decreases probability. Now, I just mentioned that probabilities are always a fraction. Well, the way to get two fractions to give you a smaller fraction is to multiply them together. If I have two fractions, and I multiply them together, my result is going to be a smaller fraction than either one of the two that I started with. So that's how probability decreases, but is by multiplying those fractions. On the other hand, if the way to get probabilities to increase is to add them together. If I have two probabilities, two fractions, and I add them together, my result is greater than either one of the two fractions that I started with. Okay? So this is all based on the idea that since probability is always a number between 0 and 1, then that explains why we multiply fractions when it's A and B, or the chances are going down, and why we add those probabilities together when it's A or B, when the probability is going up. All right? So I almost have said kind of what the rule here is. This intersection rule, the probability of A and B, is simply the product of the probabilities A and B. So the probability of A times the probability of B, that's how you figure out the probability of A and B, the intersection. On the other hand, to find the probability of A or B, all you have to do is add them together. Now, there is one little problem with adding them together, and that happens when in certain situations. So this rule that you see on the screen right before you is true in every case as long as there is no such thing as the probability of A and B. If there's any chance that the probability of A and B can happen, then we have to do one more thing to this formula. But in all situations where there is no such thing as the probability of A and B, for example, if I am considering the chances of pulling a 7 out of a deck of cards or a 10 out of a deck of cards, there is no card that is both a 7 and a 10. So there's no such thing as the probability of 7 and 10. It's just 7 or 10, and I just add those probabilities to figure out what my chances are there. But in any case where the probability of A and B does actually exist. In other words, if it's not 0. Then here's what we have to do. Here's what the formula looks like. The probability of A or B, in other words, the union of A and B, is the sum of the probability of A plus the probability of B, and all we do different is we just subtract that intersection. That's it. So it's really, it looks like a lot of stuff there on the page, and that's because probability is kind of a wordy kind of mathematics. There's a lot of symbols and a lot of words that we have to use to really fully describe these things. But it's really just one fraction plus another fraction minus another fraction. It's really not too complicated a calculation. All right? And this is the so-called addition rule for probabilities. And that's about all I wanted to kind of explain for you. I hope that you get lots of practice. Watch this video again while you're doing some of that practice if you want. And I hope that it helped you keep the ideas straight. When you multiply, that's an intersection. And when you add, that's a union. And I hope that helps you with your math practice. All right? So thanks again for watching, and please be well. Bye.